Does anyone want to tell me what marker they used or what color? Or you'd rather continue with the rest of the lesson? Shall I add anything to the year? Can anyone have suggestions? No? Should I go? Should I continue? Are you fine with whatever you tried and explored? If you did. Okay, let's continue then.
How can I change the size of the resulting figure?
This in fixed size.
Oh, fixed size, yeah.
Yeah. Okay, let's continue then. So the next thing that we want to do is saving graphs. So you have made this, you want to save them. You already, I think it was again mentioned, but we just covered again once more. It's Fig because you exported or sort of put your object in this Fig object. So now you can call it again, say Fig, save Fig, whatever name you want to give it, scatter plot, scatter, and line .png or whatever format that you like, and you can say a dot per inch resolution, and you just save it. And then when you go to your files here, it will appear. Hopefully. Here. So now you can open, you have it as a saved figure. You can also save the same thing as a PDF. If you want to do it as a PDF, you don't need the DPI anymore. And here will be your PDF. It's a bit here. You can also, when you don't define the directory, it will save whatever you have in the same directory as you opened your notebook. If you want to save it in another directory, it's only that you give it the full directory, my folder, something like that. Now, another very common issue that we deal with is that we already mentioned in the morning that it's good to have your raw data plotted. It's good to have a first visualization of your raw data to see how it looks like, and then to find out what statistics to apply on it or what analysis that you need to do on it, and how what types of things that you can get from your data. So it's good to plot the raw data, but usually we have very large data sets that makes our plot saturated. Here, from now on, we work on how to deal with large data sets and how to plot them properly to give a good idea of, to get a good idea of what the data is. For that, I'll put a link here for another data set that is a data set of the weights, the different features of a lot of diamonds that have been gathered. So this is a survey of diamond sets. Diamond? I don't know how to say diamond. Diamond. So have this link or run this line on your Jupyter lab or notebook. So you read this CBS file, and you can see that your diamond's data frame looks like this. So it has the weight in carat, the cut, the color, the clarity, depth table, and the price. So let's, if you look at the info, you see that you have 53,000 data points. So it's huge. If you plot it, let's plot it. So let's try a plotting. If you do the basic plotting, that is plot plt dot subplots. You define this first, and then use the x to say, hey, plot a scatter for me. And here, if you remember, because we are doing things in order, we don't need to say x to be caret, y to be price. It just needs to just say it. Just put the feature, the parameter set, and your data is diamonds. And you see that it's not very nice. It's saturated. You don't see what's happening. It doesn't tell you anything. So the first thing that may comes to mind is, well, let's decrease the size. So let's put the S as 1. Size as 1. Okay, not bad. Let's change the alpha as well. Maybe I can see the things better, the things that are overlapping, the dots that are overlapping. Maybe with alpha I can make it better. Let's put the alpha as 0.1. Okay, not bad. You can see that, okay, this is very crowded with, Now, what was my X? I don't remember. You know, now it's a good call that, hey, I could define the labels and the title so that I can explore the figure easier. So immediately I put the title, diamond prices. I put the X label. I set the X label, set X label, be caret. And I put the Y label, the price, because I know that's what I gave the scatter plot. Okay, so you can see that, yeah, it's very crowded in the weights under 1 and the price under 2,500. So what can I do? Maybe I can change the limit. Zoom in. So, sorry, yes.
When I label the axis value, it potentially mess that up. So
yeah.
Just label what I actually plotted.
Yeah, you mean that the scatter would, you wish that a scatter would label automatically for you based on the caret and price that you put in the scatter. Yeah. That would be really nice, but I haven't seen that. I think it's up to you. It's manual. I haven't seen any of them to do it automatically. I mean, in Seaborn, for example, in those pair plots and those, yes, it would give you. But these in Matplotlib, it's manual. It's, you know, it means to be manual so that you have the control. You do this. You use Seaborn for those high-level plottings. But this is saying that I want it to be this. So how should I do it? It's this way. So that's why they call Matplotlib the underlying package that all of them use. It's basic in this regard. So yeah, so we know that, okay, it's accumulated in this region. So we want to zoom in, meaning that we want to change the limits. So I do the set x limit x lim to be 0.2 and 1.2 between these two, and I set my Y limb, huh?
Isn't it bound?
What do you mean? Yeah, I want it to be between 0.2 and 1.2.
Because I used bound X, set X bound.
Bound, I haven't heard of bound, but let's see what it is. X bound. Huh. There's an answer for it. The bound can change automatically if you later plot something that is not within the bound. Limit is fixed. Interesting. So if your data then doesn't fit the next data that you want to fit, if it doesn't fit, it probably changes. I don't know how it changes if it doesn't fit. It's flexible, probably. It plots everything for it. Oops. It plots for you anywhere, anyway. But for X limit, if you don't have any data points in it, then you won't see anything. And my price, I want it to be limited between 200 and 4,000. So now I have a nicer view. Some other thing that you can use is that the font sizes are a bit small compared to the big figure that you have. And instead of changing them in Matplotlib, as I said, it's basic, so you have to manually change all the font sizes. But if you use Seaborn here, you can change all of the font sizes for the whole picture, the whole figure in one go. So we can do this. I don't remember if we imported Seaborn yet, so I imported again. You probably have it already. If I do this, cns.setContext, I want it to be notebook. You can change it to notebook presentation and other kinds of paper, presentation, and notebook, and I think a few other formats. But we are here in notebook, so we want it to fit the notebook. And then you change the font scale, and then the whole font, all the fonts in your plot changes to 1.3. Let's do it a bit bigger so that it's visible. It changed. See here now, everything that has a font around your figure has changed. Another thing is that you may not like these are again stylings. You may not like the frame around it, so you can do something called in Seaborn. Use the features in Seaborn and do D-spine. Now you'll have these two side frames removed, and it's a bit nicer. It's not suffocated. So this is the code that gives this data. I'll bring up the code. Sorry that both of them doesn't fit in the screen. So this is the best we could do with just a simple plotting, but again, you can see that it's not very informative still. So one thing is to add another dimension, meaning that make it like a histogram or heat map style. We can split all the our parameter space to bins and count whatever value we have in the count in each bin, and this can be done by let's first again make our frame that holds our thing. This is done by a function called hexbin. So what Hexed does for you, as I said, it divides all your surface, all your parameter space to bins and counts whatever dots or whatever value points you had in it. So if the same thing, caret and price, again, caret is X, price is Y, data is diamonds. And if you plot this, you will get something like this that is very ugly, I agree. It's because these hex bins, all of these have 0 value because we didn't have any, see in these areas, we didn't have any collected value. We didn't have any diamonds with caret of 1 and this price. But hex bin origin, by default, plots a color as zeros. So all of these zeros get the purple colors. So what you can do is tell it to just have the minimum count, mean CNT, as 1. If you have 1, plot a color for it. Otherwise, don't plot anything. So now the same, you have very similar thing as you had before, but here the counts are shown in colors. And it gives you a heat map that you can get a better idea of where you have most crowded, because you never know if this is just, for example, in this crowded area, you don't know if you have 1 dot that is plotted or 10 dots on top of each other. Now you know that, oh, it seems that it is a lot. The moment that you have a heat map, you need a color bar. So let's add the color bar. We put the axe that hex bin into an object so that we can then define the color bar. So fig color bar, I want my fig color bar to be for this HexPlot. So plot for me the color bar of this HexPlot. So I have to put it in an object so that I can call it in fig.colorbar. So now I have a color bar. So what does it say? It says that you have 2,000 data points in this area, for example. That is, again, is still not very good, but let's. But at least we have a good idea of where we are. So we now know that, okay, it's less than, this area is where you have a lot of crowded points. So let's limit my data set to this area. Now you have an idea to how to, what your data is telling you. So what I do here is I will say, okay, diamonds, I want this subset of my data.
I didn't understand how you got to the color bar.
Here. So I called my axe.hexbin. I put it in an object called HexPlot. And then I called it in fig.colorbar. I told the fig.colorbar to plot my color bar based on this HexPlot. Because this HexPlot is, when you do this, all the counts of your bins is in this HexPlot object. So now the color bar knows what to plot here, what numbers to plot here.
So can we do it without assigning the variable?
No, because you want to have your counts from this hex bin.
I mean the second line.
Yeah.
CAX.
I don't think so. See, this tells me.
It says CAX equals that. Why you give it variable?
Oh, this CAX? Yeah, I think you can. Yeah, definitely. Yeah. Okay, sorry. Yeah, it's just that it's. Yeah. You may want to then, because I did it because you will need to label it. Now you don't want, you don't remember, what was this 2000 exactly? I don't remember, so I have to have plots. And then you later go back and look at it. So now I'll define CAX. Now I can say, okay, for CAX, set label. This is, for example, observation density. Let's define everything. Set title. Let's copy and paste from above the title and stuff. Set title, X label and Y label. It's fine too, now that we're doing it. Make everything beautiful. And now you can have this observation density as your label. If you didn't put it into an object, you couldn't call it to make set label for it. That's the only reason. Otherwise, yeah, you're fine. So yeah, so I wanted to subset my data. Now that I know that my data is crowded here, I want to subset it, saying that, hey, for diamonds, get the log of diamonds that their carats is less than 1.3. Okay, we see that it's here. We want here, something around here. And the ones that their price, all the rows that the price is less than 25, let's say. Again, I have a
one diamond price.
Always diamonds. Thank you. So now, if I copy and paste the rest, and just change the data set to this diamond subset. Now I want my data to be diamond subset. Now I will have this. That is much more informative. But yet not. It would be really nice to have the histograms of the price and the weight, for example. So let's plot the histograms. For histograms, we need, because we have two histograms, we need two subplots. So I will say x1 and x2 is plot subplot into these two. I want it to be 1 row and 2 columns, and I want the fit size to be n by 4. Now, because here we will have two subtitles, I wanted to have a superior title, a title on top of the two, to tell myself that what this is. So I put a subtitle, SUP title. So I define a SUP title, call it distribution plots, and I want it to be 1.05 above my two subplots. You will see in a second. And I do this line because I don't like the frame. It makes me, I'm upset. I don't like to be confined. So X1, now I want to do the histograms. So I do hist of caret, and bins. I want my bins, I want 30 bins, and the data is diamonds.
What does bins mean?
So the histogram is the count of your values in bins. Okay. So when you say, for example, when it's 1 to 100 values, the range of your values are 1 to 100, those will be in 30 bins. So meaning that the first 30, then 30 to 60, then 60 to 90, then 90 to 100. X2 dot, so X1, sorry. So I want I wanted to have titles and labels to not mix things. So set title, make it diamond weight, and the X label is caret. Then in X2, in the second subplot, I want to plot the histogram of my price in the same bin, or it could be different, doesn't matter. I mean, you will set it based on your data, or how fine you want to be. The finer the bins, the more the bins, the finer your histogram. And X2.set title. My set title is now diamond price. Price. And my X label is set X label is US dollar. And I want it to be top layout, to not be. This spine. What is wrong with this? This spine. The spine, sorry. The spining. So now I have my distributions. Now I can get a better idea of how are the weights and prices distributed. It's intuitive that the more the less the caret, the less the lower the price, as you had before. So now we get to, again, we get back to Seaborn, and that the higher level plotting of your data. You can have the hex bin and the histograms both in the same plot. You have probably seen it in different papers that they have the histograms on the sides of their heat maps. So now you can have it with one line in Seaborn with one function that is called joint plot. Let's make the joint plot. So you call Seaborn SNS a joint plot, and you say, okay, my X, I want my X to be the caret, and my Y to be the price, Data to diamonds. And my kind. You can have different kinds. Again, you can. Now you have the same hex bin because I defined it as the kind to be hexed. It's just, you can see that these are hexagonals. So just your bins, how they look. It's very similar. You have both two things that you did with Matplotlib in one. And it also gives you the Pearson correlation coefficient. So it's really nice. There are a lot of things that you can customize in this plot. Let's do some customization to make it closer to what we saw. So this kind, we have this. Let's break it from here. Okay. Other things that you can change in this plot or customize. You can say my joint keywords, I want it to be you can call the color map. You can define the color map that is called C map. I want the color map to be Viridis. You will see that this has a lot of purple color in it, and it will be similar to what we just did with Matplotlib. I want my min count to be 1. That's the way that it uses the same keywords as Matplotlib in joint keywords, joint KWS. And then another thing is to change the marginal keywords or define them. Say, okay, I want this to be, I want the color of the margin to be indigo. Indigo. Sorry, I shouldn't have put them one inside the. Oh, and it's not equal. It's bad. It's you get similar color as we had before. You can style it as you wish. I put this up. I don't scroll down for a bit. So we changed the color map, the min count, and the color of the histograms that were plotted on the side, on the margin. So joint keywords is for whatever is inside the plot, and marginal keywords are for, or KWS is for whatever was on the side. That here was histogram. Everyone have this? Put up blue sticky notes if you have it, and yellow if you have this. Yeah,
I'm just checking the game.
Let's see what there is.
Oh, colors.
It's just joints. It's just J that is missing.
What is this everything?
It's something that is not updated. So if you update it for the latest version, he doesn't have the update as well. It's okay. It's nothing wrong with the plot. It's just saying that if you get the update, you will get the new keyword. Hex is defining what your how your inside plots looks like. If you look at them, if you go zoom in them, they are hexagons. Hexagons.
Mm-hmm.
Yeah. Again, probably by going to, let's see if the documentation has it. Sometimes the documentation doesn't have it and you have to go to different links and find what kinds, for example. Let's go to joint plot kind. So see, boring. Joint plot kind.
If you did warning about density and the keyword things, there's just a version thing within that word, and it's fine to make away and it doesn't change. That's like a heads up that.
Here. Yeah, the documentation has it here. So it can be scatter, it can be reg, it can be residue, KDE. Let's try one. Let's do a scatter. It will be don't we have a scatter here? Mean CNT. When you do the scatter, you don't have min count. You shouldn't have min count. So, of course. Yeah, it just plots the scatter plot. Let's see what the other one is. What was the other one? Regression, probably. Let's see how that one looks. Nope. Ah, cute. Yeah, it's how it wants to. Okay, it doesn't need the CMap now. Doesn't like the CMap, the color map. Okay, it just tries to plot regress a line on it. Model, yeah. Let's see what this resid is. Now I'm curious. Resid. I have no idea what this is. Very interesting. How do you have prices of negative prices? Well, I don't know. Residue over the mean.
Okay.
It subtracted everything by the mean. That's why you have negative numbers now. What is KDE? Now that we tried everything, let's try KDE as well. Yes, KDE. Takes a long time. Okay. Oh. Do you know what KDE is?
Yeah, so it's kind of like development publication. It's a smooth conversion of Histogram, but not in two-dimensional. So sometimes it's
Nice.
like different shaded regions where it comes. So before we have hexagonal links, we can have rectangular links.
Cute. That's cute. Okay. So the rest of the now. Another thing that we have to talk about is what type of plot to use to visualize our data. So let's go back to the iris dataset, the famous iris dataset. I think, did you use it in the previous days? Yeah, okay. So you know that we have three different types of flowers, and we have collected 4 measures for them. And now let's work on that to explain how can we use different plots and the features that different plots have to visualize our data better or get meaningful interpretations of them. So Imagine you don't have this. Well, we have it. Never mind. So iris. I load the iris from SNS, from Seaborn. Just see what we have. I like to do it by species, get a mean of the species. Hmm? Sorry?
Oh, yeah, that's only first.
What, iris dataset? Yeah, so iris dataset is a very, very old dataset that we have 3D species, and from these, you have 50 data points from 50 observations, or 50 flowers from each type has been collected, and from these flowers, four measures have been measured. Four
Yeah, now I remember.
parameters have been measured. Yeah, the sepal length, sepal width, petal length, petal width. So they have measured these 4 features of these flowers, and they have 50 from each species, and these species are defined by the scientists. So it may not be correct, but that's how the humans decided that these species are these. So if you want to, so you have this mean. You have the mean of all these features, all these 4 measures based on the species for each species. Let's say I want to plot. The first thing that comes to mind is a bar plot. I want to plot the bar plot of these means. Let's do it. So you probably use an SNS bar plot. You get you give the x as species as x. You give the sepal length, for example, as y, and you get data as iris. So what you get here, should I just create them just a little bit? So now you have, well, it's not very readable. I mean, it's not hide. Good, okay. So you have the mean of sepal length in the 3 species. And also you have the 95% confidence interval for each of the means.
Is that the mean, or because I thought iris was the whole table?
Yeah, but bar plot. That's what bar
plot
plots summarizes for you.
Okay.
Bar plot only, yeah, you give it the data, but bar plot does the computation for you as well. Just because we also worked on labels and stuff. Let's just do this labeling as well to be consistent. So I put X. I put bar plot into X, and then I set the Y limit. I don't want it to be that, again, confined. So I put the Y limit higher so that I have more space. It's just more beautiful. I do the set label. Remember that this was sepal length. Otherwise, you don't know which one of the 4 it was. And I don't need the X label. If you don't need an X label, you can just put it as empty string. Okay, now it's a bit better. Let me bring the code. Again, now you can let's manipulate and go between matplotlib and Seaborn and change things. Again, the same thing as matplotlib. We can put our plot into subplots and put the subplots in different axes. So I'll define 4 axes here, 4 subplots here: x1, and x2. And then x3, x4, and I make plt.subplot. So now I'm using matplotlib. I say I want a 2x2 framework, and I want the fixed size to be 10x8. And I want them to share x-axis. I want the subtitle, the superior title, to be visualization comparison. And again, I want it to be a little bit higher than the default that is 1. I want it to be just a little bit higher than the subplots. And I de-spine. I de-spine the figure. Now, for the first thing, I want to plot my x to be species, as is meaningful to do for this iris data set. Length. And my data is iris. And my x is x1. So this plots for me in x1, in the first subplot. Then I go and I want to plot a box plot. Again, this x and y and data is the same. So let's copy and paste. And my x is x2. In the third one, oops, I want a violin plot. Sorry. So again, species, sepal length, because we want to compare them. We are plotting sepal length for all of them to see how each visualize our data, the same data. And then the next one, I want it to be a swarm plot. Same x and y and blah, blah. And your x is x4. Now, one thing that is good is to set the labels. You don't want it to repeat the X label. So you want it to be empty. I like it to be plotted. Oh, no. So the 1 and 2, you don't want to have X-axis. For 2, and you will see why. For 2 and 3, you don't want Y label as well. For 2, you don't want Y label. For 3, you don't want X label. And for 4, Again, we don't want X and Y both. We want it to be nice. Okay, let's see all our different data, different plots. What? Huh? Oh, thank you. Bar-lin plot, swarm plot, perfect. Box plot and bar plot. So we are comparing all these four on the same data to see how it looks like. Hopefully I don't. Yeah. But this is comparison. Just for a second, I'll minimize it for a bit so that we can see. So even immediately in this comparison data, do you want me to bring the code, put the code for a while, put the code up? Let's see if you all have this, and then we discuss what they show. Do you all have the code? Do you all have the plot? If you all have it, please put up your blue sticky notes. If not, we come to help. And I put the code again. You should put it in parentheses. The two twos, yeah. Another one, can I see?
So here is my burn.
Can I see it again? The axes are there. Okay, then I put it in parentheses. Subplots. It's not PLT subplots. Yeah, plots. Subplots.
Yeah.
Okay, let's do it as a challenge. I don't want to jump into discussing these, but if you have these, if you all have the plot, if not, let us know to come help you. But if you have, think about what each of these show you. Either it is the raw data or it's statistics on the data. For example, the bar plot, we know that shows the statistics of the data, not the raw data, it's the mean. So, and which one do you think is the most informative? Which one do you think is giving you the most information about the data and is more helping in finding out how the relationships are between the species, for example, or between or inside the species? And we come back in 5 minutes. I mean, we resume in 5 minutes. Let me bring up the. What? You want to say something?
Yeah. No, I just feel like we've got on the entire 5 minutes, right?
Okay, less than 5 minutes. Let me again decrease it for a bit so that you can see everything. No, it's not. So what are your ideas? Which one do you like best? Or which one, or what are the pros and cons of each? Anyone wants to share their idea?
Depends on what you want to display, or what you want to get out of it. The bar plot is easier to read for the overall averages.
For what?
For getting like the averages.
Yeah, the statistics. Okay.
The box plot is easier to get the deviations or the.
Yeah, it shows more about the statistics. How variable your data is, for example, is showed in the whiskers, by whiskers. Yeah.
The violin plot is where you have the most data, like the most statistical data.
Because you have the box plot inside.
Yes.
Mm-hmm.
But it's harder. It requires more attention.
Interesting. But at the same time, it also shows a bit of the distribution.
Yes.
That is not bad.
Yes. But it depends. Like on a paper, I would put the violin plot, but on a PowerPoint presentation, I will choose better depending on what do I want to do.
Interesting. Yeah, and the swarm plot, it shows all your data points, and it's sort of good when you want to see the raw data. And it also gives the impression of the distribution as well. But it won't be easy for large data sets. It will be cramped again for large data sets. But something that is interesting about bar plot is that it's really not very good way to show what your data is. I mean, it's at some point you'll need to summarize to means and the error bars. But look at this example that we have. It's really nice to see that it can be really misleading, and it's not very professional to use your raw data set as in bar plots, because it doesn't tell anything about the underlying data set that was there. These bar plots, or these even the box plot, this box plot is the same as this, but with the two completely different underlying data points. So this will give you the same mean as 300 by only 2 data points. When this other data set A, has all these different data points. So when you're showing just the mean, you're not telling enough about your research and about your data to the audience. It can be just 2 data points that you collected, or it could be a real data set. You know, it's a bit misinforming people or hiding things from people. That is really advised not to do. So it's always better to combine if you can, if your data set allows, combine these, for example, swarm plot types that show your raw data with other statistical, with other plots that show more statistics. So let's do one example of that. Let me increase this again. Go back. Sorry, now it's too small. Okay. Let's combine a violin plot and a swarm plot so that you also have your data set. Do you want to say something? Should we stop? Oops. Okay, one small thing. We will do this combining the plots, and we are done. So let's do. It's not big enough because this combination is also nice. So we do the same fig X, is plot, subplots. So I plot a violin plot of the iris data set. So I give species and sepal length and data is iris, and I give the color to be light gray. Inner is none. I'll show you what it means. You don't want the box plot in between for now, and you want it to plot on X. Now, if you do this swarm plot, again we copy this species stuff. And we plot it again on the same axis. Now we will have both on top of each other. So now we have both the distribution of your data and your raw data points. So this is giving a lot of information to your audience. And it's nice. One little thing to say here is that you could change the order of these plots. You may want it to, it's not intuitive here for now, but you may want the swarm plot to be under the violin plot. That is done by something called Z order. Z order. I put this as 1, and I put the swarm plot as 0. It means that the Z-axis, how they are tiled on top of each other, is changed. Well, you can't see it anymore because violin plot is covering it. But if I change again to the violin plot to be 0, then you can see it. So you could change the order of things.
Can you repeat how we use the order?
Z order. So whatever 0. So you put one as 0 and the other as 1. And if you had another thing, for example, let's say I want
higher number goes on top, or
0 is before 1. So if you do this, whatever has 0 is the first plot that is plotted. Then whatever is 1 is the second plot, the second thing that is plotted. This could be 10, doesn't matter. Whatever higher number is plotted after the first, over the other ones. So I can add something else. This is not at all meaningful, but I can add a, let's say, box plot on top of them. But if I want it to be, let's say, the violin plot to be under everything, The swarm plot is after that. I can give it 5, doesn't matter. And then the box plot on top, it will be something like this. Or it could be 1, 2. As long as the numbers are ordered. The order of the plots are is the order of the Z order variable. That's it. Well, we had a little bit of information about the colors and how you can use different colors and get use of the color maps. But I think we don't have time.
It's in the notes.
Yeah.